Fantastic. Broadcast is started. So, hi guys. My name is Prince Makawa Abudu. I'm a current student at the University of Oxford doing my PhD in computer science, going into my third year, focusing on machine learning and AI in embedded systems and resource constraints systems. And today, um, I'm really happy to be joined by Utkarsh and Obehi, and also the students from St. Dominic's, Chishawasha, for our technology panel session, which I find very intriguing because I do have been trained in tech, so and I want to have a career in tech. So this should be very useful for people that are interested in technology, and if not, then hopefully this will be a very, very good motivator for you. So before we start, it would be good to really know everyone who is on the panel. I just gave a brief introduction of myself, but it'd be good for Utkarsh to introduce yourself, and then we'll go to Obey. Then we can start with the questions. So over to you, Utkarsh.
Hey everyone. So it's morning here, so good morning, I guess, and good afternoon for you guys. So my name's Utkarsh. I'm a product manager at a in a California company, and so what I do is I work with hospitals to make hospitals more efficient. And I have a very similar background to Princess, where I also have a degree in computer science. And I'm currently getting my master's in artificial intelligence and machine learning as well. So very similar to kind of what Prince is getting, except Prince is getting his PhD. And that's it. Yeah, let's dive more into details over the course of the session. And I'm also gonna be joined by my friend Bharadwaj. I'll let him introduce himself, but he'll be joining the panel as well.
Fantastic. Over to you, Obey.
Okay, so I see the video call ended because the connection was lost. Can you guys hear me?
Yeah, Obehi, I can still hear you.
You're very much still in the call, yeah.
Oh, that's very interesting. Okay, well, I can't see anyone, but I also work at the same software company in California with UV. I work as a product manager there. My background is very different from UV's and Prince. I studied mechanical engineering, and then I went on to do manufacturing engineering for my master's. My manufacturing engineering was more focused on operations research and manufacturing operations in general. So if you look at supply chain, if you look at logistics at companies, so that's how I did translate that knowledge, at least the manufacturing part of my education, into helping cancer hospitals with their infusion operations. So while UV works with sort of operation rooms, I work with cancer infusion centers. So you have patients coming in to get their treatment. And then what we do with our software is how do we improve the scheduling of the patients to come in for their treatments such that you have them waiting less overall. So if you go to the hospital today, you might end up waiting 1 hour before you can see the nurse or the patient. How can we make sure you wait only 10 minutes instead? But we can go more into the details later of what our software does, but just my background is mechanical engineering and manufacturing with some operations research, and then being able to apply that knowledge in a technical environment or in a software tech. I grew up in Warri, Nigeria, in the motherland. I moved here for college about 10 years ago. And ever since then, I do try to go back home maybe once or twice a year. So I look forward to getting to know everyone and spending time with you guys.
Excellent. Thanks so much, Obey. Utkarsh, would you like to bring Bharadwaj?
Sure.
Sure.
I'll go ahead. My name is Bharadwaj, guys. So it's hard to pronounce. I'll go by Brad instead. But yeah, I had a similar background, just similar to Utkarsh. We both went to the same college, did our computer science undergraduate, and I've been working as a software engineer at a large corporation called Salesforce, and I've been working at Salesforce for about 4 years. And I used to be in San Francisco, but I recently relocated to Vancouver. And I currently work with the predictive analytics team where we use machine learning techniques to try to get the information from the customers and try to predict on, try to predict on their data and give them more insightful information than what a general analytics company would do. But yeah, I've been a software engineer by training, and I'm currently also doing my master's in computer science.
Fantastic. Yeah, thanks so much, guys, for the fantastic introduction. So in the room, we also have, like I mentioned before, students at St. Dominic's. Most of them have finished their exams, the final exams. Some of them are en route to start their final exams in a few months. Most of them do sciences. No, some of them do sciences, some commercial, some arts, which is just a way that the Zimbabwean government kind of puts people in buckets to say, if you are commercial track, maybe you want to get a career in finance. If you're the science track, is more like the sciencey stuff and artsy stuff, things like that. So I know that we've been throwing around the term machine learning a lot because it looks like most of the panelists it's like our point of intersection. So maybe Utkarsh, you can briefly demystify machine learning so that the high school students in the room can really understand what that is, especially given that in Zimbabwe it's not yet very popular.
Sure, yeah, Prince. So let me just give you guys an example of how machine learning might be used. So, traditionally over the years, as things got more complicated, as computer programs got more complicated, the way computer programs work is there's a person that understands what the problem is in the real world, and then build something that the machine can understand to be able to complete it, right? To be able to solve that problem. And so the person really has to know what the problem is, and the person has to know what it is that needs to be fixed. But what we've been doing in recent years is, instead of telling the machine exactly how to solve the problem, all we do is we tell the machine how to learn to solve the problem. So we don't necessarily tell the solution to the machine, but we just give it some rules. We say, hey, this is how you can solve this problem. This is the problem. These are some of the rules that you need to follow to be able to solve the problem. Why don't you experiment and learn how to solve the problem? So the machine does this stuff by itself. And so I'll give you guys an example. If you use email, there's a lot of times there's really emails that are not very relevant to random emails that you get, or spam. You guys might have heard of the term spam, right? Emails that come from random people that you might not know. So how do you pick out which emails are important, which emails are not important? So we actually use machine learning in that as well. So we let the computer understand what's important, what's not important, and automatically select that for you based on some rules. So that's kind of what machine learning is. It can be applied to many things. These days, we're even trying to apply it to stuff like self-driving cars, which are cars, that kind of almost drive themselves. You don't really need a driver sitting behind the car. The car kind of understands how to drive itself on the highway and tries to make adjustments, etc. So there are a lot of ways that it can be applied. But I guess the main point to remember is that the computer itself is learning how to do a task rather than being told exactly how to do a task. Would you like to add anything to that, Prince?
No, I think you did explain it perfectly. Perfect. The take home is really to teach a computer or a machine to learn, just like what humans do, right? So that's really fantastic. So I'll go ahead and over to you, Obehi. Just state again what your job title is within the company, and then just really walk us through what that title means and what it entails.
Okay. So I am a product manager at LeanTest. As a product manager, or the job function or roles of a product manager is really a role where you get to design a product from scratch. It's where you get to figure out what is the problem you're trying to solve. How can I solve this problem with a product? Is there a market for my product? Who's going to use my product to solve a problem? what features are going to go into my product. The features, are they technically able to be built? Can they overlap with other features? As a product manager, you get to work with engineers, you get to work with data scientists, you get to work with marketing, you get to work with supply chain, you get to work with customers a lot, right? So in the product management role, there's sort of two subcategories in which they group them. You could either be an inbound product manager or you can be an outbound product manager. As an inbound product manager, you're more focused on further developing the product. You're on a day-to-day basis. You're looking at what new features can I put into the product. You're looking at how do we build these features? How do we prioritize which features we want to go into the product? For example, if you want to have a particular filter, for example, say you're in a shopping website, and then you are filtering by prices, or you're filtering by, you want to order the list of your product by price from cheapest to most expensive, or you're looking at from, you want to filter by boys' toys or by girls' toys. These are all features in your software product. So as a product manager, you decide what features you want to go into that product. So, and you typically you have a roadmap. You have a roadmap of as many as 10, 20, 100 set of features you want to go into your product. So you're planning how you want these to go, how they interact with other subsystems in the product. You're working with engineers to, drive that these features have been built into the product, because the engineers are they're working on so many other products, they're working on so many other features. So you kind of have to be watching them and poking them and making sure that they are working to fix your own product and fix your own problems and your own list of features. So you're also doing quality engineering, quality assurance. So whenever an engineer, for example, then fixes a problem for you, you then have to go test it out to make sure they fixed it right.
Yeah.
So all of this I'm explaining is stuff that happens on the inbound side of product management. Right now, on the outbound side of product manager, that's where you're working more with customers on a daily basis. You're trying to see how do you evangelize the products that you guys have made as a software company. How do you take this to the customers and solve a particular problem for the customers? So in our case, our software is a predictive tool. Basically, it helps improve the scheduling of patients coming in for their appointments in a cancer center. So we're going to these customers to figure out, how are you currently scheduling your patients to come in? Are you saying, I want a patient to come in at 9 o'clock today? I call the patient on the phone, hey, when can you come in today for your appointment? Or a patient just walks in and say, hey, I am sick. Can you treat me now? Right? So we're going to these customers and we're learning how they're doing it. Do you have 10 people coming in all at once for their treatment? Do you have people calling in to say, hey, can I come at 5 o'clock today so you can treat me? How many nurses do they have? How many doctors do they have to treat all these patients? How many chairs do they have to treat these patients? How many rooms? How many injection? Well, not on the injection level yet, but basically we're working with the customers to see, how do you operate on a daily basis? And then we're taking that input back and seeing how we can classify that amount of information and put it in our software. And our software, like UV said, talking about machine learning, it's a machine learning based software. It takes all this information and then you're teaching it based on that information you're collecting from the hospital. And it's applying all these algorithms and math and statistics. And it's saying, what is the best way I could then take all this information, such as how many patients am I seeing in a day, how many nurses, how many beds, what's the best way I can then tell patients to come in for their appointments. So it collects all this data over time, 6 months, a year worth of data, and it learns about the patterns. Only 5 patients coming on Friday. On Sundays, is nobody coming on Sunday? So it looks at all these patterns and then sees how you can better optimize it and say, hey, if a patient comes in every 30 minutes, everyone will be happy and they don't have to wait as long as they used to wait before. So, and I guess I probably went around to explain that, but in a product management role, you can either be more focused in inbound role, where you're working more on the software features themselves, you're developing the technical aspects of the product, or you could be in an outbound role where you're working with customers on a daily basis to figure out how best to solve their problems and to use your software to solve their problems.
Great stuff. Yeah, thanks so much, Obey, for explaining really the role of a product manager. So you'd imagine that most technology companies or companies in general would have, who sell some kind of product, would have someone to manage that product. So another example of a product could be like WhatsApp.
Yes.
All the students in the room use WhatsApp.
Exactly.
So that blue tick is a feature, and someone has a job to decide, like, we want the blue ticks now, and this is what it's going to communicate. So it's really important role. Thanks so much. So I'll go over to Badwaj to just help us, like, explain the role of an engineer, especially of a software engineer, and maybe any other role you have undertaken, and just explain that to us, because I know that most students would, when you hear engineer, you're thinking like things that you can touch, and but software is very, very different kind of engineering. So can you just explain that a little bit?
Sure, sure. So as Obehi was mentioning about inbound product manager and how did they deal with engineers and have to deal with them on a day-to-day basis. So an engineer's job is basically to get requirements, product requirements from the team itself. So in the sense, a team is usually a bunch of engineers, a product manager, in these days, data scientists, because everyone is trying to implement machine learning. And so once we get the requirements from the product manager, where, in this case, the blue tick, we essentially get that information and see what our situation is. So it's essentially problem solving at the basic of it. So when you think about it, you have a problem here in the sense that you have a product without a blue tick, in this case, WhatsApp without blue tick, and you're trying to solve it in the best way possible as an engineer, right? As an engineer, you're dealing with whatever is given to you, right? In this case, you are working with softwares, different kinds of softwares, which are part of your product. So, for example, I think Lean Task has a stack of JavaScript and other languages, and especially for machine learning, I think you guys use Java, correct? And cool. So even in large corporations, there are different languages which you deal with, right? You have Java, you have C, you have Python, you have Scala. There are multiple languages. So an engineer's usual task is to work with these languages, work with the languages, and work with the product and the product manager to understand the requirements and build something. So it's essentially taking a few Lego boxes or basically a building blocks and build it together and make sure that, hey, this is what we have, and this is what the product is, this is what the requirements are. And so I built this particular thing so that the outbound product manager can take it and sell it. But in general, overall, the task of an engineer is to get the requirements from an inbound product manager, see what the requirements are, understand what you're working with respect to the languages, and build the product together with that language.
Great stuff. I think, this is excellent. Just really seeing the perspective of, how you move from the requirements, which is essentially what has to go into the product, and making it a reality and actually building this software. So I'll come to you, UV. Perhaps just briefly summarize your role and kind of tell us a little bit more about your dreams when you were in high school, right? So did you always know that you would be in this role? Or is that something that just came by opportunity or circumstance? Like, just bridge that gap. In high school, did you dream that you'll be where you are today, and what has changed if it wasn't the case?
Sure. So let me get to that second part of the question in just a bit because it's the answer is a bit complicated. But before I get to that, let me kind of tie together what Obehi was talking about and what Bharadwaj or Brad was talking about. And what I want to do is I actually want to show you guys what like a normal company's workflow looks like. So you have all of these different types of people that are working in a company. Obehi and the company that Obehi and I work for, it's a bit smaller. We only have about 100 people, which is a pretty small company. The one that Bharadwaj works for, it's a massive company. It's like a Microsoft or Google or one of these really big companies. So they have something similar, I'm sure, but it's kind of set up differently. But I can kind of show you how we do things. So let me share my screen really quickly, and let me know if you can see it. Can you guys see my screen?
Yeah.
All right, great. So, like I mentioned, there's a lot of different people that are part of uh, any effort when you want to get something done. And so there are engineers, there's designers. So designers are the people that create everything. So they're the people that actually say that it needs to look like this, or it needs to have this color, or it needs to have that color. And finally, you have the engineers like Bharadwaj who go in and actually build a product. So we use a lot of tools to help us kind of manage that. And product managers are really the people that are in charge of the tool. So if you look at what I'm showing here, every single one of these cards is actually something that needs to be done on the product. So it's something that it's a problem that needs to be solved. So for example, over here, we're saying show who is logged on in mobile. So that's just tracking for our mobile app. Who are the users that are logging in, logging out? This one says surgeon mobile settings page. So for our mobile app for surgeons, we want to add a settings page. And what you see over here, all of these people, they're the person that's currently in charge of completing this task. And you can see there are several columns over here. There are these columns over here. And what these columns essentially indicate is how much of that task has been completed. So that this first column, can all of you see this? It says backlog. So it's just every single thing that needs to be done is put into this column. So every single task that needs to be completed, regardless of whether we've started it or not, is put into this task. So there's a lot of different tasks here, right? There are many things that need to be done. The second column is ready for development. So once we know exactly which task we're going to complete this week, what we'll do is we'll pick this up and we'll drag this over onto one of these. So let me actually pick one of my tasks so that way, let me assign this to myself. So that way everyone doesn't get notifications for it. Okay, so you can kind of move it over. So say I'm ready to kind of hand this task over to the engineers or someone else. I'm going to move that over here. Every one of these tasks actually has more details to it, right? So let me pick one that's a bit simpler. So show who's logged on. So once I click on that, I'll tell the engineers what it is that needs to be done. So for instance, the context for this is when logged into mobile view, it's impossible to know what account is being used. And this is an internal problem. And then you can see that there's a spec attached to here. So we've attached some more screenshots and stuff to help people understand what it is that needs to be solved. And then finally, there's some people that are leaving comments on it. And so once the engineers are ready to pick up a task, they'll put it into the in progress column, which is column number 3. So they're just gonna pull it over and they're gonna put it into in progress. Once they complete the task, so this is when someone like Bharadwaj works on it. Once he completes the task, he's gonna put it here, which says awaiting code review, which just means that Bharadwaj's boss or the kind of the manager of the engineers will go in and make sure that everything is correct. Then they'll give it to PM review, which is where someone like me comes in and make sure that the task is actually completed, that everything that needs to be solved is solved. And finally, we're going to move it to down a couple of these things and into ready for merge. And that's when it actually becomes part of the product or becomes live on the product. So that's kind of how a task works. And we have several of these, like I mentioned. So that's kind of how we keep the task flowing, if that makes sense. Any questions on that? Do you guys does that kind of make sense?
Yeah, I think so. It's it's a really comprehensive process, right? And this is really what shows you that um, the entire product life cycle is composed of like so many intricate details. And you'd think that maybe a simple application or simple piece of technology would take like one person to build, but really in reality, it's an entire team around it and all these tasks that you have showed. Um, so yeah, so students, if you have any questions, just take a note, and then we'll definitely leave some time for that. Um, but I just really wanted, I was also like curious to understand like why people sort of get into certain careers, and
Mm-hmm.
maybe Obey, you can quickly go into like how did you get into technology? Like, yeah, put plainly simple.
Okay. So how did I get into technology? I think it's better I start with how I sort of got into mechanical engineering first. So coming out of high school or secondary school, which we call it back home, um, I took my technical drawing class, which we used to call it TD back then. It's a class where you do construction drawings. You can sketch out how how a machine might look. I took my physics classes. I really liked physics. I don't know if you guys take physics there, or if it's like a science, if you guys are science students or art students. But basically, I picked up this interest in science and physics and building stuff, doing technical drawings, and then I decided, okay, I wanted to do mechanical engineering for my university. And university, I started seeing how much broader mechanical engineering was. You could be doing thermodynamics, which is studying energy in systems. You could be doing fluids, which is how things flow, how air flows, how water flows. Um, or you could just be constructing products. You could be designing physical consumer products, like you could be designing your mobile phones, you could be designing your laptops. Um, Towards the end of my university study under mechanical engineering, I got more interested in manufacturing, which was how do you actually make these products that people design, these physical products. In learning some of those, I then got more curious into the business side of things. And the business side of things in manufacturing is how do you plan your manufacturing operations? So yes, you have all these products you have to make, but then there's a whole distribution and supply chain around it. There's a whole network of where are you going to make this? How many are you going to produce? What volumes are you going to make? What inventory are you going to keep? Like your mobile phones that they make that you all have. When they're making these, they keep a stock inventory for people to place their orders. So how do you replenish your inventory and make sure you always have enough made to meet the demand? So there's a whole demand and supply chain in manufacturing that you have to work with. So then I went into the manufacturing side, and I did learn both how do you physically go saw or welder or cut a piece of metal or a piece of wood to make your product. So for phones, for example, it could be if your phones are mostly plastic, how do you go about cutting your plastic or molding your plastics? How do you go about the intricacies of the circuit design in your phones? So I sort of went from that to the distribution of them. And then I actually worked in a semiconductor manufacturing plant, which is where in the manufacturing role, I am basically creating a workflow around how do you make your chips, the chips that are in your phone. If you take apart your phone and break it, you're gonna see different chips. How do you test those chips to make sure, hey, by the time it comes to productions, you have enough chips ready to go into those phones. These are chips that have passed the quality test. So if you make 100 chips, most likely 5 of those chips will be bad, only 95 will be good, right? So you go through this manufacturing process of filtering out the bad quality products and making sure in your batch, you have at least 95 to 99% of that batch of chips are good for your phones. So for example, you wouldn't want to order a phone and see that it's bad, right? So we make sure you get very good phones. So in manufacturing, I came out of that and I said, hey, I've been working more with physical products. I've been working with chips. I've been working with phones. I've been working with cups. I've been working with widgets. How can I apply this to a more tech product, to a more technology product, right? I've been on the hardware side. I was like, I want to broaden my experience. There's a lot of money in software and software products. Hardware products take a longer time to build. There's life cycles of at least a year for some hardware products. A phone, for example, might take at least 5 to 6 months to really develop, or even a year, and then to go into market and to go into mass production. But then in a software product, you have much shorter life cycles. You can build a software product in 2 weeks. You can build a software product in 1 month, and you can start selling it, and you can start making your money on it very quickly. So I had been in this world where I'm working on products that take a year to go to market from when you first design it. So I'm like, how about I diversify my experience and work on software products as well, build my software skills. So then I moved to the Bay Area, where I actually worked as a software engineer for about 3 years. So I got my hands dirty in software development, in software quality testing. I used to work for Oracle, which was a database company. I used to work with servers. And then I got the opportunity to then work for LeanTask as a product manager, which was where I went from, testing tech software to then designing and selling software products. So it's kind of like a long path where, I really got interested in designing and building products upfront, but it was more mechanical engineering products, more physical hardware products. And then over time, I decided, hey, how about I diversify my experience? How about I work on products that go to market a lot faster? And that's really what got me interested in software. And I'll tell you this, there's actually a lot of money in software too. So those were very convincing things to lead me to go into software technology. So.
Oh, great! Thanks so much for walking us through the entire journey, because I mean it's very easy at such a young age to make the assumption that things kind of just fall into place, or opportunities just get handed to you sometimes. And it's weird also because you have to always create this balance between like what opportunities and what you really like, right? And getting these small experiences, like internships, or in Zimbabwe, students have a chance to like work with different companies as attaches, and those small experiences will really inform where you go in the long run.
Yeah, and I'll add to that by saying you never really know what 10 years from now is going to look like. You don't know exactly what you want to do. You think you know what you really, really want to do. You have an idea of it for the most part. Some of you might know, those are the lucky ones. But for a majority of the people, you have an idea of what you want to do. And as you go along your journey, it just starts becoming clearer and clearer what you really want to do. So don't think, oh, how did they get there? How did they know they wanted to do this since secondary school? No, it's not always like that. So.
And just to kind of add to that, I think, some of the most successful people I've met in my life, the person that's founded our company, our manager, a lot of them didn't actually work on anything related to what they work on today. So I think it's important to, more so than anything else, to just be curious, always keep learning. Like, you should never stop learning. There's always more things to learn. There's always different types of problems to solve. So curiosity, I think, is the most important thing. If you're curious about things, if you want to learn about different things, then you'll eventually find something that you're passionate about. So don't kind of bucket yourself into this or that, because I did my high school in India, and it's very similar to what I'm hearing from you guys, which is we also had like arts, commerce, and science. And so even before you were like 16, 17, you were kind of forced to pick a few subjects over other subjects. Like if you picked art, you wouldn't be able to do the science subjects anymore. If you picked science, you wouldn't be able to do some of the commerce stuff anymore, and stuff like that. But you know, there's many ways that you can end up on a particular career path. So it's more important to just keep learning so you can find that thing that you're really passionate about, or really that you enjoy. Because ultimately, if you enjoy something, you're going to be good at it. That's kind of the important part.
Yeah, and I mean, and the most important thing additional to that is to have a leap of faith. So if you you trust your gut about something and you basically take a leap of faith and you know, try it out, and that's how most people end up where they end up, because they essentially have the courage to try out something new and learn something new, and then, you know, they stumble into success essentially.
Oh, excellent, excellent. And yeah, I think you raise a very valid point, both of you guys, Utkarsh and Bhadraj, in terms of like just be curious. Like it's very important just to be curious and want to learn and find out new things about new information about different things that are growing, especially in technology. It's ever evolving. And the point on leap of faith, I think we all on this panel, we have the advantage of age, and that means that we can take risks and like learn new things and just dive into it and just be great at it. So let me just maybe ask one more round of questions, and then we can open up for students, because I'm pretty sure that they'll be curious. But maybe starting with you, Bhadraj, just tell us, what do you find to be the greatest perks of having a career in technology?
Could you repeat that? Sorry.
What do you find to be the greatest perks of having a career in technology?
So, as Obey, he said, you make a lot of money. That's number one, and that's the biggest thing. But another thing is that with technology these days, right? Everywhere around you, see anywhere around you, there's technology. You know, you have technology in the place you sleep. You have technology in the place you work. You have technology everywhere you see around you. There's technology. So the massive perk which you have while working in technology is that you're connected to what's going to happen around you, around the world. So essentially, you are part of something which is essentially changing, and you can be a part of it and you can contribute it. So the opportunity for contributing towards the change of the society and the world around you is the biggest perk you can think of, right? And considering it's one of those things where, you know, technology is, you know, the big word these days, and essentially everyone is into it, and everyone is trying to adapt technology into their spectrum, right? You have psychologists trying to adapt technology. You have you basically every single even artists, they're trying to, you know, enable and implement technology in their spectrum. So essentially, you are being you being a part of technology, you can have multiple, you know, variations of whatever you like. So for example, if people who like art or who like soccer, for example, they can go, or football, for example, they can go work for EA and essentially build games using technology and essentially contribute something towards something they like, right? So, so that's the biggest perk. Essentially, you have the opportunity to be a part of something greater, and also have the opportunity to, you know, explore new things in the field of technology.
Yeah, fantastic stuff. Fantastic stuff. Obey, would you wanna jump in on that? Like for you, what do you see to be the biggest perks of having a career in technology?
So biggest perks I would say of having a career in technology is being able to meet so many people. So I'm not gonna touch on the money anymore. That's a given fact. But being able to meet so many different people, different calibers, different experience levels, because technology is such a product that you can apply in almost everything you do these days. You could be working for NASA in an aerospace company, and there's a lot of technology there. You could be working for Apple, a phone company, and there's a lot of technology there. You could be working for Google, and that's all technology. So basically, across a broad range of spectrum of different career paths, even teaching, for example, they bring technology into teaching these days. How can you teach remotely? How can you have more analytics-based learning? How can you have more technology-based learning? So pretty much with technology, you have this hub where different career paths can come together, right? So then you begin learning from different people and different industries where you can apply technology, build your skill sets, and just if you keep learning and you're curious about how something works, you could find yourself going into a completely different industry that you never thought you would be in. So for me, one of the biggest perks of technology is just being able to network with so many people and just being able to just learn, being able to keep learning across different people, across different industries. So for me, that's one of the biggest things.
Oh, great stuff. We'll go over to you, UV.
Sure. So these guys touched on a lot of things that obviously I also care about. But the biggest perk I think about working in technology compared to anything else is that technology is kind of the great equalizer, right? So because technology moves so quickly, as long as you understand it better than anyone else or you understand it well, you're on the same page as everyone else. So it doesn't matter where you come from in life or what education you have or what opportunities you have had so far or how much money you have right now. None of that really matters as long as you understand technology itself, because it's moving so quickly that no one really has an advantage over anyone else. The only thing that helps you is knowing what you're talking about or understanding the problem and understanding the solution. So I really enjoy that aspect of it, which is I just need to be good at what I do. I need to be good at understanding what the problems are. And then, people will listen to me, right? People will listen to what I have to say. People will um, uh, receive impact from what I do. And the only reason for that is because there are no kind of advantages or disadvantages to starting from somewhere or not starting from somewhere. It doesn't really matter because technology moves so quickly. Like 10 years ago, no one had cell phones like we do now, right? And now we have all of these applications and all of these companies built on top of cell phones. Or 20 years ago, we didn't have the internet. So things change so quickly that the market's always changing, and it's very exciting to keep up with all of the new things that are happening. And I think that's the biggest perk of working in technology, being really close to the newest stuff that is happening currently in the world.
Fantastic stuff. Yeah, and yeah, you did mention really something, interesting about like how technology continues to evolve, and all of you guys mentioned about how all different careers now incorporate technology. So it's becoming like a prerequisite for people to teach different technologies, especially in school, and a good point on like problem solving. And like in high school, mostly what they're teaching is to have an approach to problem solving. Then when you go to like undergrad, they're teaching you to know something generally in a field. When you go to masters, to be more specific, and PhD even much more specific, right? So it's important like how you approach problems and how all of this like comes into your career. So I think I just want to maybe ask Badwaj to, if you were to be 16 years of age or like 18 years of age today, what advice would you give to yourself?
So I think the best advice I would, or the advice I would give myself is um, do what I like, but keep technology close to you. And what I mean by that is pretty simple. So essentially, everyone has their their interest with respect to art, sciences, or anything else, right? So, for example, I was really interested in becoming an astronaut, right, back in the day. So I would highly suggest that you follow what you want to do, right? You like if it's your true passion, just follow it. But at the same time, keep computer science and technology at your heart. So essentially, you want to make sure that you are covered and you are in the technology space because that's, as we talked about, it's the field to be in, right? With respect to the opportunities and the perks and the benefits. So the best thing to do is make sure that you cover all your spaces, do what you love to do, at the same time keep technology at your heart. So that's the best advice I could give anyone who's 16 or 18 right now.
Excellent. Thank you so much. And Obehi, what would you tell young high school age going Obehi?
At this age, what would I tell a younger self? Myself is just be curious. Just put yourself out there. Just go and learn. In every single class you take, learn. Learn, do your research. Early on, start talking to people who are older than you. Start talking to your seniors because they have the best advice you can get. They've been through it. They've been through it. They can tell you which paths to take. Get mentors really early on. They will tell you, hey, which path should you take for your undergrad? Your undergrad is going to be really important. Although you can go out of undergrad and still go different career paths, if you can pick up a lot of skills early on in your undergrad, start now. So now, so you guys are about 18. How many years before college, Prince, do they have? How many more years before undergrad?
Less than a year now.
So you have less than a
year
year
of the high school, yeah.
Okay, so you'll be getting ready for SATs for those of you who will be fortunate enough to, go to the US or the UK taking the A levels. Just start talking to people in those schools. Start learning the classes in those schools and start early. Don't wait for 6 months from now. There's application cycles. Deadlines are due in December. For the UK schools, I know their deadlines aren't due till maybe May or April, but start early. Start getting ready for those classes now. Start taking the preps. Start reading the books. Just start early. Everything you do, start early. Don't wait. And then if you don't know exactly how to start, just talk to someone who's done it before. Don't wait for them to bring the information to you. I had a lot of friends who would be slackers, who would wait for their parents to tell them what to do, who would wait for their older brothers to tell them what to do. Some of you might not have older brothers, or some of you might not have parents telling you what to do. So it's up to you. It's your responsibility to go look for the information out there. So just be curious and ask questions. If not, you're just going to be behind everyone else who did. So just be very proactive about your career. Be proactive about you wanting to learn, and don't wait for anyone to come tell you what to do. Push for it instead. Don't shy away. You will fail. Sometimes you will fail. Sometimes you will look stupid asking questions, but don't let that hold you back. We all went through it. We've all asked very dumb questions and people have laughed at us. But hey, you're learning. From every time you fall, you're learning to not fall again like that. So that's my biggest advice to you.
Thank you. Thank you. I feel like we definitely need a book from you guys like careers in tech. Excellent stuff. Over to you, UV.
Yeah, I mean, Obey kind of covered it, like there's, and honestly, there's always questions you can ask. There's always more you can learn. Like I still ask stupid questions. I asked stupid question like yesterday, and people laughed at me. So that stuff never ends. Just kind of keep learning. And what I would tell myself if I was 16 is, I used to kind of do that, which is, wait for like someone to tell me, or wait for like the school to tell me, or the college to tell me, or I used to do things because they were required, because I need to finish these things to finish my application, or I need to finish these things to get into school. And so it used to be very outcome driven, right? I only used to do things because they were necessary to do. And what I would say is do things because you want to do them, right? Beyond just because they're necessary. Like do things that you enjoy doing. Do things that you feel passionate about. If you're curious about something, learn, have a bias toward action. Like always do something rather than thinking about it, right? Like if you're kind of wondering whether to do something or not do it, always go ahead and do it. Like experience it and then learn from it, right? It's okay to fail. So if you have an idea, if you want to build a mobile app, if you want to build a website, do it. There's nothing stopping you, right? There's no one stopping you from doing that. So always have a bias toward action, right? If there's an option between doing something and not doing something, always pick the option where you do something. Never just wait for someone to tell you to do something. No one's going to tell you that, right? Even in life, you ultimately have to decide whether or not to do something yourself, right? It's your life. And so that's what I would tell you. You know, don't wait for direction. Don't wait for necessarily people to tell you. Go and do what you would like to do. Try to improve your own life. Try to better yourself, right? Every single day, try to be a better version of you. That's all I would kind of tell myself, because I think it's sometimes hard when there are so many different requirements and stuff, so many tests, so many exams to really you know, think about why you're doing what you're doing. So that's what I would encourage you guys to do. You know, don't just do things because they're supposed to be done or they're required. Do things because you want them to do, or ask yourself why it is that you're doing some things, or what else you could be doing to that you would enjoy, that you're passionate about.
And to
Fantastic.
add to that, to add to that point, I think he mentioned another thing is, do not dwell on failures. Right. The thing with failures is it kind of can be disheartening if you're trying to go for a goal. The best thing to do is to learn from the mistakes and not make the same mistake again. But don't take the mistake as something, you know, negative and go into the negative loop. That's another thing which can be very helpful, especially if you're 16 or 18.
Excellent. Yeah, thank you so much, guys. Yeah, I mean, this is just fantastic advice, and I think we wouldn't trade it for anything. I'm learning a lot also from you guys, and definitely I'm going to have to look up to you guys because I'm going for a career in technology as well after finishing school. So I'll just open up to the students just to ask whatever question that may come to mind. Remembering that there's really no stupid question. So um, over to you, students. You can unmute your mic, come up in the front, say your name, and ask any of the panelists a question, or just ask a general question, whatever that interests you when it comes to this panel. Okay, yep, go ahead.
Mm. I am Majita Kundishwa. And I have a question in terms of computer science. If you're studying computer science, do you first have to choose which IT path, like program, you want to focus on, or you are first introduced to the programs that are part of computer science, then you'll choose later after your first degree?
Yeah, so Majita, what programs are you referring to? Do you mean as in like the programming languages, or you mean like a specific focus?
I mean, like the different categories involved in computer science. Let's say there's software engineering, there's program designing, and stuff
Yeah.
like that.
Okay. I can take that one. Even though I didn't study computer science, but I'll tell you this: you're starting off, you don't know what programming language you're going to use, right? It's good if right now you're learning one programming language. If you're learning Java, if you're learning Python, if you're learning C++, that's great. But going into college, going into university, you are exposed to a variety of different programming languages. In a computer science degree, you're exposed to various aspects of computer science you can go into. It's good if you have an idea of which one you want to do on the long run, which one you like doing best. But in college, in university, you will get exposed to different aspects of computer science. Then you can then decide which ones you want to specialize in. So usually your first year of university, they expose you to different aspects of it. So they don't expect you to choose upfront what section you want to go into. So like when I started, mechanical engineering was really broad. I didn't know exactly which focus in mechanical engineering I wanted to go into. It took me 4 years after college to still decide which path I wanted to go through. And I came out of it and I'm not even doing any of it anymore. So really it's going to be it's going to be up to you to learn during that process when they expose you to the different languages to decide which one you like doing best. And then go with what you're passionate about as well. But then you don't get to decide now.
Yeah.
You can have an idea of what you want, but you don't get to decide now. You don't have to put that pressure on you to decide what program or what part of computer science do you want to go into. It's too early to limit yourself like that.
Yeah, fantastic. And
Yeah, just to
yeah, go ahead, UV.
sorry. So just to add to that, I think so. When I studied at Georgia Tech, you know, the way I think it kind of works is computer science or any subject that you want to study, right? It's there's a lot of information to take in, right? Like there are many things to learn, and so the way it usually works is for your undergrad, you try to learn as broadly as possible. So you learn as many different things that go into computer science as possible. And usually you do a lot of this in your first 2 years. So in your freshman year and your sophomore year, or your first 2 years of college in the US, you learn a very broad approach, right? So you learn the basic things of everything. So just like a little bit of all types of computer science knowledge. And then as you start understanding that, you can start kind of picking some of the classes that interest you more. So you can start learning a little bit deeper in the parts of computer science that interest you. Once your undergrad is complete, if you're doing a master's like I am, then you pick a couple of those categories and you learn even deeper about what's happening. But you're still only learning what's already being discovered or what someone else has already created. You know, this stuff already exists. And then if you do something like a PhD like Prince is doing, you're going even beyond that. So you're not just learning what other people have discovered, you're discovering something yourself, right? So you're not at this point even learning something that has already existed. You're taking a new problem and you're creating something new, something that no one has ever done before in that particular small piece of computer science. So that's as deep as you can possibly go in one of the categories. So to answer your question, really, you don't need to make up your mind right now, right? Just study all of the different things that are a part of the umbrella of computer science, and then think about what you like, and then you can start exploring that a bit more. And as you go deeper and deeper, more opportunities will start presenting themselves, because every single one of those subtopics is also very deep. There are a lot of things to learn even within each subtopic. And finally, you know, there's even PhD. You know, some people do research for the rest of their life. They keep doing that. They keep discovering new things for the rest of their life. So it's really up to kind of what level of depth you want to go to with each of those subtopics.
But an additional point to that. So to add to it, I mean, the thing is to focus on understanding the fundamentals, which you learn in the first 2 years of college. Once you understand the fundamentals of computer science, you can apply that to any different subgroup, because at the end of the day, it's all ones and zeros. So if you understand the fundamentals well, you can apply that to any of the subgroups, and you can choose at a later stages of.
Yes. Yeah. So I hope the question was answered. Do we have any other question?
Yes.
Okay. Come
Yeah.
up. Yeah, you can go ahead.
Remember, there's no stupid questions. Just go for it.
Yeah. Come up and let's hear the next question.
Hello?
Hi.
Hello.
Okay, so my question is directed to Obey, right?
Okay.
Your field of study is something that's really interesting, and it could help mainly countries in Africa, considering that we have a lot of people who will be queuing like at hospitals and all that. But then I want to understand that for you to introduce something like that in Africa, should we first deal with our technology advancements first, or we can just introduce it as Okay. Introduce it because I'm one individual who would want to study abroad, but then come back home and practice. So is this
Yeah.
something that can actually be practiced in a country like Zimbabwe, for instance, and help solve the problem at hand? Or you have to first improve the technology in the country and then you introduce something like that?
Okay, so that's a very, very good question. And in places where we implement our software, yes, there is a lot of advancements in technology that are in place to help us do what we're doing. And for up until 10 years ago, it was impossible to do what we're doing right now. The only reason our company was founded and our company was born was because of a major breakthrough in technology, which is called electronic health records. So up until about 10 years ago, all your patient records, all your activities were being done manually. Everything was written on paper as to because of security reasons, you couldn't just put information out there online or in computers. So up until electronic health records was built, which is basically a data warehouse for a patient's workflow, a patient's records. When a patient comes in for an appointment, even a patient has an appointment 2 months from now, we can go in the system and see that a patient is coming in 2 months from now. So up until that technology platform was built, we couldn't make this company, right? So yes, for a place like Zimbabwe and most hospitals in Africa, it will be a challenge to do this. I'm from Nigeria. I know the condition of hospitals back home. We don't even have lights. We don't have electricity, not to talk of having a technological platform to store data. So up until a lot of those infrastructure are built, we cannot do the software. So you're absolutely right. There are some cases where you can bring some technological solutions to problems, but they're advancement levels. So coming back home to do something, you will have to go to a much base level to create a platform before you can then build a software on top of that platform that can do what you want to do. So to bring our software back to Africa right now will be a very big challenge. So that's not possible. It would take EHR to first come into Africa before LeanTask can come into Africa. So I hope that answers your question.
Can I add something to real that Obey? So
Yeah.
one thing I think for all of you ladies, I think is that you guys have a really great opportunity because if you, for instance, come and study in the US or the UK or like you get exposure to new technology, it's not like things are perfect here either. You know, things are better. You know, it's not that things are perfect, though. There are a lot of mistakes that people have made in how they've implemented a lot of these things or the EHRs that OBE was talking about. These are not perfect systems. So I think a great opportunity for people like you, you know, that want to go back and do something, you know, in your home country, is you can avoid the mistakes that have been made here. So you can understand how it is that these Western countries like the US or the UK have done certain things like hospitals or, you know, infrastructure or things like that. And you can think about how to implement that in an even better way, right? Because what you have when you don't have any existing solutions to a problem is you have a blank slate. You can build whatever you want to build. So you can really start thinking about whether the things that currently exist are the best solution or whether there's an even better way to do something. So I think with, you know, a lot of development comes a lot of opportunity. And so you can always think about how to apply things in not just the way that it's been done right now, but in a different way, in an entirely different type of implementation, or you know, think about how to do something better. So I think it's kind of important to understand how things currently exist and then to apply that to your own situation, because no one understands Zimbabwe as well as you guys. You know, you live there, you understand where your problems are better than anyone else. So who better to solve the problems than you, right? And so understanding how solutions have been implemented in other parts of the world and then applying that to your specific problems is something that no one else can do as well as you. And so that's an amazing opportunity that I think all of you have.
So just never stop thinking. Again, start from what is the problem and how can I solve it? Again, once you put yourself out there, you keep learning. You keep learning what other people are doing, and then you think, how can I translate this back home? hey, I know we have this problem back home too. It's just like everyone else. Why can't I do it? And then how can I do it better? But always make sure there's a problem you're trying to solve. Because if there's no problem, you're just going to go around in circles. So always look for the problem you're trying to solve.
Excellent. Yeah. Thank you. Thank you so much, guys. And this makes me remember of some platform called EcoCash, which most Zimbabweans now use for like mobile money and transfer. So the guy who founded this platform went to Kenya and then found out that they were using this thing, and in Zimbabwe there was nothing like this, and built this in 2011, about 7 years ago, and then now it's made the company jump from $32 million in profit each year to $150 million in profit, like between now and last year, which is quite impressive to just see like how you can get exposure in different countries and then come back and implement it. So if something is not here, that's the challenge for us, the young people, to make it happen. I think we'll get the last question so that we can wrap it up. I know that there's so much to learn, and we definitely need more time for these things. So students, anyone wants to have a last question?
No.
Oh, you sure?
Yeah.
Okay, excellent. I think we should give a hand to all our panelists. Guys, really, really thank you, UV, Obehi, and Badwaj. If you guys have anything you'd like to say before we wrap this up, then it's all up to you guys.
Just keep learning, guys. Just keep learning. Keep learning.
Yeah. And again, the world is your oyster. Make it happen, whatever you want to make it happen. Yeah. You have the opportunity to do it, and just make it happen. Create opportunity if you want to, but you have the world to yourself. Make something happen.
Awesome.
And whoever it was that was shy to ask a question, don't be shy. You're never going to learn that way if you keep shying away from asking questions.
Yeah, excellent. Anything from you, UV?
No, I just want to say, thanks for giving me the opportunity to talk to you. It's always fun attending these Emergination panels. So looking forward to more of this in the future.
Fantastic. Yeah, I'm sure these students loved it. You can hear from what they're saying. So this is really, really beautiful. Thanks so much, guys, and until next time.
Thanks, guys.
All right, thanks everyone. Thanks, Prince.
Right. Thanks, guys. Thanks for setting this up, Chris.
Bye. Bye. Bye.